it's not the greatest room to lecture in, but we'll try our best here, I suppose. All right, so we're going to talk about nomenclature, which is a fancy way of saying naming, not really, but I guess it's a fancy way of saying how to name things. And when we talk about nomenclature, we're really going to be talking about sort of two types of naming, and they do revolve around sort of the bonding that we talked about. We're going to talk about how we name ionic compounds, which, as we know, are metals and nonmetals together, where we have our metal transferring our electrons and creating a cation, right, and an anion, which is that no sharing of electrons happening there, complete transfers, that electrostatic attraction, holding those guys together. We're going to also talk about how we name what's sometimes referred to as covalent or molecular compounds. And these are really guys where we have kind of our two nonmetals. These are guys that are basically held together by sharing electrons, right? So depending on the type of bonding that we have going on, it does affect sort of how we go about naming them. So before we sort of talk about naming, a reminder that especially with ionic bonding, we have ions. And when we look at the periodic table, as I think we've talked about, but just to remind everybody, things in group 1, right, will form a +1 charge. Things in group 2 will form a +2 charge. Things in group 3 will form a +3 charge. That's mainly aluminum there in group 3. We kind of skip group 4, group 5, and these are really the nonmetals. Will be -3. Group 6 will be -2, and group 7 will be -1. And once again, those minuses are those nonmetals above the staircase, is where we're talking about. Our transition metals, as we talked about, perhaps have a variable type of positive charge. There are 3 exceptions, and the 3 exceptions are zinc and cadmium. They do have fixed charges, and they will make a +2 charge. And silver, if you kind of hang a leftover there by cadmium, will make a +1 charge. So these are typical elements that when they do make charges, they have fixed charges no matter what the situation is. That is always going to be their charge. And that's, again, obviously really important to remember as we go through sort of this naming. I think the other thing that we talked about in that, I feel like it was like the end of chapter 4, maybe we talked about it. Whenever we do put ions together, right? So whenever we take anything that's like positive and negative, that should look familiar to you, by the way. That's also perhaps how it should be drawn, by the way. When we put these guys together, we actually need not one, but we do need 2 of these guys. Now that's really how it should be drawn, just so you know. To balance it out, and that would give us a formula MgCl2. So when we put these guys together that are ions, anytime you put a positive ion together and a negative ion together, it does have to equal 0. And the reason for that, as we talked about actually in the bonding chapter, is that allows everybody, right, to reach noble gas configuration, right, to get to that same electron configuration as the noble gases. That's really the point of it. All right, so let's get into some of this naming. First off, there are certain things that, regardless, are pretty much named through common names. And it is not a trick question when you see H2O on the exam or quiz. It is water. So just put water. Don't put dihydrogen monoxide. Nobody wants a refreshing glass of dihydrogen monoxide, right? They would rather have a refreshing glass of water. NH3 is ammonia, which is not to be confused with something we see a little bit later on, which is a polyatomic ion of ammonium, which is NH4 plus. But the NH3 plus is ammonia. We don't call it nitrogen trihydride. And CH4 is methane. That is the simplest organic molecule you can have. And so those 3 for sure should always roll with the common names for those 3 guys: water, ammonia, and methane. So let's talk a little bit about naming these things. There's really 2 classes of compounds, as we just talked about. We have our metal and non-metal, which is going to be ionic. And again, there are certain rules involving naming when we're dealing with ionic compounds. And again, our two nonmetals that will be sharing electrons, which are covalent, which again, there are a certain set of rules in terms of how we go about naming these guys. So we're going to start here talking first off about ionic compounds. So ionic compounds are sometimes broken up into two types, a type 1 and a type 2 ionic compound. And type 1 and type 2 ionic compounds are both the same. They both have a metal and a nonmetal. And again, we're going to get that transfer of electrons going to happen. I would say in the case of metals and nonmetals, whenever a metal's involved and you need to name it, it is always that metal that is the most important thing. So the metal is always really the one that determines how you go about sort of naming the whole thing. So when we do write formulas for ionic compounds, as we might have also talked about, it is always the positive guy first, followed by the negative guy. And that goes both in the name and also the formula. So like I just wrote a second ago, MgCl2, that is the positive ion first, negative guy second. And when we go to name this guy, we will also do positive guy first and then negative guy second. So let's first, though, talk about, before we get specifically into type 1 and type 2, how we name just ions by themselves. So if we just have some ions by itself, things with charges, how we go about naming them. And as we might have talked about here, if you have a cation which is positively charged, like H plus, like Na plus, like Ca2 plus, we simply just use the whole name of the element. So this would be the hydrogen ion. This would be the sodium ion. This would be the calcium ion. So whenever you have a positive ion that's present, you basically just use the entire element name. You don't do anything really to it. When we have anions, which are negatively charged ions, like H minus, like Cl minus, like O2 minus, we actually drop the last part of the name and maybe a little bit more than that, and we replaced it with IDE. So these guys end in IDE. So hydrogen is actually going to be hydride IDE ion. Chlorine becomes the chloride IDE ion. And oxygen becomes the oxide ion. So they all end in IDE. You might notice that hydrogen can be positive, hydrogen can be negative. It's the only element that can kind of go both ways. So typically speaking, most of the time, hydrogen will be positive. The only time that hydrogen will actually be negative is if it comes after a metal. So like if you had LiH, then that would be the hydride version of it, and it would be negative. So if you find hydrogen that comes after a metal, then it's going to be the negative version. Otherwise, it's most likely going to be the positive version. Any questions on that there? Okay. So let's talk a little bit more about the type 1 and type 2. Erase what I scribbled there. There we go. Now, what makes something a type 1 and type 2? As I mentioned before, it is an ionic compound. And again, always when that metal is in the mix, it is really the one that you want to look at. So what makes something a type 1 or type 2 is actually the metal. And a type 1 metal is ones that have fixed positive charges. So those are what we were just talking about. Those are our group 1, 2, 3, our zinc, our cadmium, our silver. All these guys have fixed charges, bless you. And that means that it's a type 1 compound, and that will have a certain way of naming it, as we'll talk about in just a second. Now, a type 2 compound are where the metals have a variable charge. So as you can see on the bottom there, chromium in certain cases can be +2, or in other cases it could be +3. Copper could be +1 in certain cases, could be +2. Iron, for example, could be +2, +3. So in the case of a type 2 metal, we actually need to figure out what the charge is because it can be variable. And these are typically our transition metals. So typically our transition metals are just to the right are our type 2 guys. So our type 2 are typically transition metals, except for obviously zinc, cadmium, and silver, and just to the right, below the staircase. And what I mean by that is things like lead and tin and so forth. So if you look at the periodic table, there's our transition metals, there's our staircase. These are our type 2 in here pretty much. And down this way, where again we have things like lead, tin, and those kind of guys are also sort of included with it, antimony, bismuth, Bi. They're included with type 2 because they can make variable type charges. So remember where that staircase comes in. Below the staircase are metals, above the staircase are non-metals. That's why when we talk about group 5, 6, and 7, -3, -2, -1, we're talking above the staircase. The non-metals is what we're talking about in that particular case. Any questions on that so far? So here's a table of some of just the names of some of the ions. And as you can see here on the left-hand side there, everybody is positively charged. So again, simply just the whole name of the metal or the whole name of the element. And our guys on the right there are all negatively charged, and they all have that IDE arrangement at the end of it. So let's talk about type 1 compounds. So as I mentioned, it is that metal that you want to look at. And that means that when you're trying to name something, probably the first thing that you really want to sort of figure out is, am I dealing with a metal and a non-metal, or am I dealing with two non-metals? So that's kind of the first thing that you want to deal with. If you find yourself looking at it and it's a metal and a non-metal, that should tell you it's ionic. And once again, because the metal's involved, if it is a fixed positive charge, that then will tell you it is a type 1 compound. The nice thing about a type 1 compound is, frankly, that's once you figure that out and you have the formula, you're ready to name it. You don't have to worry about anything else other than it's a type 1. I'm just going to name it like I should. The way you should name it is you use the whole name of the metal, and the non-metal, you drop the last part of the name, and you get the little IDE action. And that's it. So for example, since I did that one earlier here, a little Mg, was it Cl2 in this case, right? So when I would look at this to go name it, I would look at the magnesium and go, that is a metal. I would look at the chlorine and go, that is a non-metal. That right there tells me it's ionic. Because the metal's involved, I'm going to look at the metal. I'm going to go look at the periodic table, and I'm going to see that magnesium is group number 2 on the periodic table, which means it has a fixed positive charge. Because it has a fixed positive charge, that tells me it's a type 1, which means I just roll into my naming. Whole name of the Mg is magnesium, right? And the chlorine becomes chloride, and that would be magnesium chloride, right? Now, the question that you're asking, let me answer it for you. I know you're asking this. What about the 2? Don't I need to fancy it up by putting like a dichloride on that? No, unless you like an X on your paper, you should not do that. There is no place for prefixes. And it's a very common thing people do. They see the 2 and go, oh, I know I should probably maybe do that somewhere. No prefix at all, ever, when you have a metal and a non-metal together. Never use it. So you don't do it in this case. You could have 400 of the Cls there. It would still be called chloride. You could have 200 of the magnesiums. They would still be called magnesium because it's a type 1 compound. So you don't do anything other than that. The reason, obviously, we have the 2 there is what we drew earlier, right? We need 2 of the Cl minuses, right, to balance out the +2 charge on the magnesium. So this magnesium chloride formula, which is MgCl2, does not have a charge, but it is made up of a cation. And if you were asked to draw or write the formula for just the cation would be Mg2 plus. And the anion formula, by the way, would be Cl minus, not Cl2 minus. There's no such thing. So it'd be Cl minus. Again, the 2 means you have 2 of those, right? So if you're asked to write the formula for the cation or the anion, they do need to have charges. Otherwise, they're not ions. So if you are asked to write a formula for an ion, you do need to include the charges. But when you put them together with the positive and negative to make an ionic compound that contains both the metal and nonmetal together, should have no charge overall, should be put together in the simplest way to get to 0. Any questions on that there? All right. I was going to add, I think, at the end of that, but that felt wrong to say, I suppose. So here again, as I just mentioned, if we had something like sodium chloride, although the formula for sodium chloride, which is NaCl, we would see that's a metal, that's a nonmetal, tells me it's ionic. Sodium, which is the metal, is the important guy there. That's group 1, which means it has a fixed charge. And that means I could just roll to the name of sodium chloride in this case. Although it has no charge to NaCl, it is made up of a cation that has a positive 1 charge and an anion that has a -1 charge. When we look at Ki that's on the bottom, we would do the same sort of thing. K is a metal, I is a nonmetal, tells me it's ionic. The metal is the most important thing. That is group 1, which has a fixed charge, tells me it's type 1. At that point, I could roll right into my name of potassium iodide. Yeah. Again, the iodine gets the IDE treatment. That is also made up of a cation that is K plus, right? And an anion that is I minus in this case. Again, +1, -1 gives us 0 when we put it together. Yeah. Any questions on that there? All right. All right, so why don't you take a moment and name these? Why don't you also write the formulas for these things here? Let's do lithium nitride. Let's do, I don't know. Let's do, I just did that one. So let's do barium chloride. And let's do a little aluminum oxide. All right, so I want proper names on the left, proper formulas there on the right. Okay, let's take a look and see how you're doing. So again, we'll start with the formulas here, and we want to give the names. So really, you want to look at it and see what you're dealing with. So again, here we have K, which is a metal. We have Cl, which is a non-metal. So right off the bat, that tells you this is ionic. It is always the metal that's the most important guy to look at, and that K is in group number 1, which means it has a fixed charge. So that's going to tell you it's type 1 that we're dealing with at this particular point. So at that point, really, that's all you need for the naming part is to identify it as type 1. We're going to use the whole name of the metal, which in this case would be potassium. The non-metal is going to get the IDE at the end of it. So chlorine will become chloride. This is made up of a cation, right? That is K plus, and an anion that is Cl minus, which is why we just have 1 of each when we put it together in that formula. Question on that one there. Looking at the next one, again, we have zinc, which is a metal. We have S, which is sulfur, a nonmetal. So that's going to be an ionic compound as well. Zinc is a transition metal, but is one of those 3s that we talked about that has a fixed positive charge. So it does fall underneath type 1. So that does tell us as a fixed positive charge. And once again, at this point, that's all you need for the naming part of it. We're going to use the whole name of the metal, which is zinc. And sulfur becomes sulfide, IDE, at the end of it. This is a cation, right? That is zinc with a +2 charge, and an anion that is sulfur from group 6 with a -2 charge. And again, that is why in the formula there we have just one of each, because +2 and -2 gives us 0 when we put it together. Any questions on that there? Rolling to the next one, we have calcium, which is a metal. We have Br, which is a nonmetal. So once again, that tells us it's ionic. The calcium, which is the important part of that, that's the metal, is group number 2, means it has a fixed positive charge. So that tells us it's type 1. So we'll roll with the whole name here of our metal, which is calcium, I think. And bromine becomes bromide in this case, yeah. So a little calcium bromide. Once again here, it doesn't matter that there's 2 of the Brs because we need them there to balance out the positive charge, right, that we have here on our cation in this case. Any questions on those so far? Lastly, there in the corner, we have barium, which is a metal. Hydrogen, remember, is actually a nonmetal. So in this case, that is also going to be ionic. Barium, which is group 2, has a fixed positive charge, which means it's type 1. So I'll just write the name here. That's going to be barium. And this is going to be actually the negative version of hydrogen. So that is going to be hydride, because the cation in this case is Ba2+. The anion is H-. So this is a situation where hydrogen is going to be negative because it comes after a metal, and that's really the only time hydrogen would be negative. Once again, the 2 there for the hydrogen has no effect on the name. Any questions on any of those names? Yeah.
For the last one, we did 2 Br negatives. Did we do that for hydrogen?
Yeah, so honestly, the truthful answer is if you were asked to, for example, to write the formula of the anion, H- is perfect. You don't have to actually put 2 of them there. Same thing with the Br. You could just write 1 Br-. So usually if you're asked to do write the formula of the anion or cation, they just really want the formula of one of those ions of what it is. Yeah. Yeah. Other questions? All right. So now we have names and we want to write formulas for them. So you should really approach this the same way. Lithium is a metal. Nitride, IDE, means it's from the periodic table probably, and it sounds like nitrogen, right? So that is basically lithium and nitrogen. Nitrogen is a nonmetal. Lithium is a metal, which tells you it's going to be ionic. So right there, you know you're going to have ions. So you just want to write the basic 2 ions that there are. So lithium is group number 1, which means it has a +1 charge. Nitrogen is group 5, which means it has a -3 charge. Remember, whenever we put a positive and negative together, it needs to equal 0. So in this case, we need more of the lithium, right? We need a grand total of not 1, not 2, but 3 of them, right? So essentially, you could just write what you just did there. I wrote 3 lithium, so that is Li with a 3 to the right. And I only have 1 nitrogen, so that's an N. And now I am done. Yeah. I would recommend doing it this way or thinking about it this way as balancing out to 0. And what I mean by that is people are very commonly taught to like flop the signs, go up, go down, and do a diagonal move. Like, hey, take this way, take that way, or go backwards. And it does work for 94% of the time, but there's a lot of times where if you just blindly sort of swap the charges down, you will get the wrong formula. So it's better to sort of think about it just balancing out to 0. You'll make sure you get the right numbers of each of those things, but you might see people teach you just kind of swap them, and it doesn't work 100% of the time. For the next one here, we do have barium, which is a metal. Chlorine, basically, which is a nonmetal. So again, it's going to tell it's ionic. The basic form of barium is right there, Ba2+. And I'm just going to steal what I got over here. Or why not, since I have it. And chlorine, or chloride, which is group 7, is a Cl-. So again, we want to put these together in the simplest way possible. If you're not sure how to do that, you can just multiply the two charges, right? 2 times 1 is 2. So get everybody to 2, basically. So I do need one more of those guys. So basically at this point, I have one barium, which means I write Ba and 2 Cls. Remember as well, the subscript always goes to the guy to the left, right? And if there's nothing written there, it is assumed to be 1. Any questions on that one there? Lastly, we have aluminum, and I'll go towards the top because I know it's kind of hard to see in here, so I'll erase some of this here. Kind of move it up towards the top. There. All right, so aluminum is a metal. Oxygen or oxide is a nonmetal. So we're going to do the basic unit there of aluminum. That is group 3, which means it has a +3 charge. Oxide is oxygen, which is group 6, has a -2 charge. Common number there between the two is 6. 3 times 2 is 6, right? So to get oxygen to 6, I need not 2, but I need 3 of them. To get aluminum to 6, I need 2 of them. And now I can just count what I got going on there. I got 2 aluminums, so Al2, and 3 oxygens, O3, right? And now I have the right formula. Any questions on type 1 compounds, fixed positive charges? Yeah. So obviously you need to be able to write the name if you're given the formula, and you need to be able to write the formula if you're given the name. Any questions on type 1? Now, before we move off of type 1, we're going to talk about something that is sort of treated like a type 1 metal, even though technically speaking, it's a nonmetal. And that is hydrogen. So hydrogen has a lot of unusual sort of characteristics. And let me just kind of get rid of some of this up here so we can talk about it. So when we have hydrogen in the beginning, so for example, if we had something like HCl, we actually would think of this, even though it's technically 2 nonmetals, and even though technically, as we just drew it, it is sharing electrons and covalently bonded, it is oftentimes in terms of naming thought of as being more like a type 1 ionic compound. And what I mean by that is the hydrogen here is thought of as being H+, and the Cl is Cl-, and is thought of as being really more ionic. And that's really because that is the forerunner to hydrochloric acid, which when it does go for a swim to become hydrochloric acid, it becomes ions. So that's why people sort of think of it in that sense. So when we do have hydrogen in front, we just simply use the whole name like a type 1 and just call it hydrogen. And this would be chloride, which would be like the hydrogen chloride gas. Even if you had 2 hydrogens in front and it's not an acid, say it's something like a gas in each of these, this would be 2 H pluses and 1 sulfur that's -2. And that's why there's a 2 on the bottom there next to the hydrogen. This would also be called hydrogen sulfide, which maybe you'll smell a little bit of it when you go to 1B. Not pleasant at all. And this is hydrogen sulfide gas, not good for you either, so you shouldn't really smell too much of it. It's hydrogen sulfide. So hydrogen, even though both of those things are really covalently bonded together, sharing of electrons, in terms of naming, they're really thought more of like an ionic compound, and it's more so because they typically will become acids and they will become ions at that point. So that's how we sort of treat hydrogen that is in front. That's sort of positive. Any questions on that there? All right, then that means that if we did type 1, there must be type 2. So let's talk about type 2 and the major difference here. So type 2 is still ionic, which means it is still a metal and a nonmetal together. And still, it is the metal that is the most important thing here. And in this case, we're going to have a metal that has a variable positive charge. So these are our transition metals. Obviously, except for zinc, cadmium, and silver, are again just to the right where lead, tin, and those guys are located. The difference between type 1 and type 2 is simply the metal can make a different positive charge. So when you name things, you actually need to tell people what charge you're talking about in this situation. So we actually name this very similar to how we do type 1. And I'm going to kind of get rid of this so I can write a little bit higher here. We actually will use the whole name of the metal, just like we do in type 1. We will actually do the non-metal with the IDE, just like we do in type 1. So we'll do our non-metal with the IDE. The difference is in between those two, we put a Roman numeral. Bless you. And the Roman numeral is the positive charge on the metal. Like if you took one metal out, what the positive charge is. It is not what most people confuse it to be how many metals you have. It's not how many metals you have. It is if you took one of those positively charged guys out, what the charge is. So the Roman numeral is the positive charge on the metal. Again, not the total positive charge, just one individual positive charge of what it is. So if we look at the example that we had there, the approach that you should take in this case is the exact same approach that we did previously. We're going to identify what we're dealing with. Iron is a metal. Cl is a nonmetal. So that tells me it's ionic. Fe, which is the metal, is the most important thing. If I look on the periodic table, dead center of the transition metal region, lucky number 20 something, 6. Lucky number 26, I think, is iron, which tells you it has a variable charge and that this is a type 2. So what that means is you need to take perhaps an extra step to figure out what the charge is on the metal. The good news is you will always know the charge on whatever it's attached to. So whatever that metal is attached to, you will know what the charge is. So if we take this, for example, all right, I know I need to figure out what my charge is on my iron, but I do see Cl there, and Cl is group number 7 on the periodic table. And that means that it should have a -1 charge. But there's not just one Cl there, there are 2, which means I actually have that happening. That's going to give me a -2 overall, which means my one iron must have what type of charge to balance it out? +2. Now I have everything I need to name this. I'm going to use the whole name of the metal, which will be iron. I'm going to lay myself up here a Roman numeral of 2 because that is the charge on the metal. And just like in type 1, it does not matter how many of those nonmetals you have, it is still just going to be called chloride. So this would be iron Roman numeral 2 chloride. First off, any questions on that? The reason we need to use the Roman numeral is if I had FeCl3, in this case, I would have an iron, I'm maybe not sure. I still have a chloride, but now I have not 2, but I have 3, which means I have a -3 overall. And in this case, the iron actually has a +3 to balance it out, right? And we need to tell people in this particular case, we're talking about iron with a Roman numeral of 3 or a charge of 3, and this would still be chloride. So we use the Roman numeral with type 2 metals to tell people what the positive charge is. And again, that is what the Roman numeral means. You take one of the positive charges out, and that is what you should have there. The rest is pretty much just like the other one. Yeah. Question on that there. So if I had something like maybe that's pretty much what we just talked about. This, what should this name be? PB is lead, by the way. Take a moment and write the correct name for this guy. Got it. So PB is lead, which is a metal. Oxygen there is a non-metal. So we know this is ionic. The lead is not a transition metal, but it's one of those ones to the right that does fall under type 2. It can have a variable charge. So we do need to figure out the charge here. So we do have one lead. We do know oxygen is group 6, which means it should have a -2 charge. And there are 2 of them. So if my math is correct here, that is -4. That means the lead here is actually carrying a +4 charge. And the proper name here would be lead Roman numeral 4 oxide. This would not be lead 2 oxide, which a lot of people will get because they just blindly move the 2 to the top. And so this is again an example of, if you've ever seen that or be taught that, you will get the wrong charge on both of those if you move those guys to the opposite side. Any questions on that one there? It would be not correct in this case. So you should not use, just like in type 1 in an ionic compound, type 2 is an ionic compound, you should not use prefixes. Other names for this, there are a older way of naming these type 2 compounds. We're not going to really use the older name here in this class. We will strictly use Roman numerals for type 2, but sometimes people will still use it, especially for iron and copper is very common. So in the older way of naming, use kind of the root of the historical type name, and the one that has the larger charge would end in ic. The one that had the smaller positive charge would end in us. So iron 3 would be ferric, and iron 2 would be ferrous. Same thing with copper, cupric, and cuprous is sometimes used still, but we will not use those names. But that's sort of the reasoning. What it is, ic is the higher positive charge, os is the smaller positive charge. So again, we'll strictly use that. Here's a table of some of that and some of the older names. We're not going to worry too much about it, but you can see a lot of it is sort of really where they get some of the symbols from, by the way, for some of these things. The one thing I did want to mention is mercury, which is an oddity. This is mercury plus 2, 2. That is mercury plus 2. The first one, oddly, with all the 2s, is mercury 1. Yeah, so that has mercury 1 there. The one with only 1 2 is mercury 2. And that is because mercury 1 comes as a dimer, which means there's 2 mercury 1s stuck together, which is why they each have a +1 charge, which is where the +2 charge comes. And there is 1 and 2 of them, which is where the bottom 2 comes from. So the one with more 2s is actually mercury 1, and the one with less 2s is actually mercury 2. The way that you're able to recognize that is the bottom 2 still hangs around when you see it in a formula. So for example, if I had this Hg2Cl2 and HgCl2, top one is mercury 1 chloride, and you would need the Roman numeral. Again, that extra 2 is hanging out there. The bottom one is mercury 2 chloride, no 2 on the bottom. So that extra 2 kind of hangs out there, and that's how you kind of know it's the mercury 1 sort of ion. Any questions on that there? All right, so we kind of went through this. Same rules apply for our type 2. The only really additional thing we're doing is adding that Roman numeral to indicate the positive charge on the metal. And like I said before, you will always know what is attached to it. So just like last time, let's do some names on the guys here on the left. And again, I'll write it up towards the top in case it's hard to see. And I'll give you some names that you could write formulas for. So why don't you write the formulas for, let's do iron 3 oxide. Let's do copper 1 sulfide. And let's do chromium 4. Okay, let's take a look, see how you're doing. So again, we're going to identify what we're dealing with. CO here is a metal, Cl is a non-metal. So once again, that tells us it's ionic. Always when that metal's involved, that's where you want to be looking. And that cobalt, again, right next to iron there on the periodic table. It's a transition metal, which tells us it has a variable charge. So that's a type 2 compound. So we want to, again, sort of figure out our charge on our cobalt. We do know that Cl is -1 from being from group 7, and there are 3 of them. That means to balance it out, our cobalt would have to have a +3 charge to do so. That means that this name here would be, I'm going to go right here underneath, cobalt Roman numeral 3 because of the charge. And again, doesn't matter how many we have, will be chloride in this case. Yeah. Any questions on that one there? Looking at the next one, Cu is not carbon, copper is copper, which is a metal, I think. I is iodine, which is a non-metal. So once again, that tells you it's ionic. We're going to look at our metal as our important guy there, and that's going to be a transition metal there, number 29. And that means we have a variable charge. We do know that I is group 7, has a -1 charge. So clearly to balance that out, we actually have a +1 charge on our copper. And this would be whole name of our metal, copper, Roman numeral 1 because of the charge, and iodide, ID. Any question on those two? Lastly, we have tin, which is a metal, and Br, which is a non-metal. Tin, again, is a little bit to the right of the transition metal, but in that area where they still have a variable positive charge. So we got a tin, I'm not sure, but we do have Br, which is group 7, which means it should have a -1, and there are 4 of them, right? So we got a little bit of this happening. That gives me a -4 overall, means my tin should carry a +4, and this should be tin Roman numeral 4 because of the charge, and bromide. Any questions on any of those names? Yeah? All right, so working backwards from the name to the formula. Get rid of my cobalt there that I wrote. The nice thing about the name is when I see iron Roman numeral 3, I know the iron has what type of charge? +3. That is what it means. I don't have to figure anything out. It actually told me what the charge is. Oxide is oxygen, which is group 6, has a -2 charge. So when I put those together, common number there is 6, right? And to get iron to 6, I would need 2 of them. So I would need like 2 of these guys. To get oxygen to 6, I would need a grand total of 3 of them. And we should end up with something that looks like this. Yeah. Looking over here to copper Roman numeral 1, that tells me my copper is carrying a +1 charge. Sulfide is sulfur from the periodic table, which is group 6, has a -2 charge. In this case, I need more of the copper, grand total of 2 of them, which means I should have 2 coppers, right? That's where the number goes to, and 1 sulfur in this case, right? Or something that looks like a 5. There you go, make that more of an S. Any questions on that one there? Lastly, chromium Roman numeral 4 means my chromium has a +4 charge. Bromine, which is group 7, has a -1 charge. Once again, when we put this together, we're definitely going to need some more of the Br minuses. Grand total of 4 of them, which means I have CrBr4 in this case. Question on type 2, names or formulas. Yeah. So exactly like type 1, except the additional thing, you need to figure out the charge and put the Roman numeral in there. There has been no prefixes, right, with Roman numerals. And if you find yourself like Roman numeraling and prefixing, just make an X for yourself as well, because it's probably going to be wrong. Yeah. So there's only one little spot where that might occur, but it definitely is not when any of these situations. So you should never really have a Roman numeral and a prefix kind of rolling together when you're naming. Any questions on any of those two types? All right, then let's talk about, this is just a summary here of what we just talked about. Again, group 1, 2, 3, zinc, cadmium, silver, no Roman numerals needed. Transition metals, and just to the right, do need Roman numerals, as we've been talking about. So let's take a look at a few more here. HGO would be what? Do I need a Roman numeral or not? Hg is mercury, right? That's a metal. Oxygen is a non-metal. Mercury is found in the transition metal, which means it does need a Roman numeral, right? And oxygen here is a -2. That means the mercury here should be a +2. And is this mercury 1 or 2? This is mercury 2. And this is mercury 2 oxide because there's not an extra 2 down there, right? So there's no extra 2 on the bottom. That's how we know that it is mercury 2. How about MgBr? Do we need a Roman numeral? No, because Mg is a fixed metal, type 1, which means we could just go whole name, which is magnesium. And bromine becomes bromide, right? Li2O, does it need a Roman numeral? No. Li is group 1, which means it has a +1 charge always. Type 1, which means we could go right into the name of lithium oxide, right? Bottom guy there, just in case it's too low to see, is CrF2. Do I need a Roman numeral on this guy? I do. Chromium is a type 2 metal, transition metal. So we do have F, which is group 7, and there's 2 of them. That means in this case, my chromium is carrying a +2 charge. And this would be chromium Roman numeral 2 because of the charge, and fluoride, right? So chromium Roman numeral 2 fluoride. Any questions on any of those there? All right, so little decision tree in case you need help with the decision. We sort of been talking about it there. Well, we've been talking about don't use prefixes, don't use prefixes. Here's where we use prefixes. So this is where you should use prefixes when you name these things. And these are type 3 binary compounds. Binary just means there's 2 elements. But type 3 means it is 2 nonmetals together. And 2 nonmetals together means we're going to be sharing electrons. And this is really the place where we actually do use prefixes. We're going to have 2 nonmetals together. And we will use our prefixes like mono is 1, di is 2, tri is 3, tetra is 4, penta is 5, hexa is 6. There's a table coming up, I think, that has these. Hepta is 7, octa is 8, a little nona maybe, I don't know, 9, perhaps some deca, maybe some 10. And these are the prefixes that we use. So here's how we do it. You'll have 2 elements, 2 nonmetals together, and you know that makes it a type 3 compound. And we will use the prefix if needed and the whole name of the first element. We will then use the prefix, and the second element gets the normal nonmetal treatment of IDE at the end. So we kind of prefix them and then IDE at the end. These are probably the easiest ones to do and probably the ones people screw up the most on because they want to do all kinds of weird things that they don't need to do. So try not to do that, by the way. There are a couple of rules that we follow when we're doing this. The first major rule is we do not use mono on the first name. So we do not use mono on the first name. but it is okay on the second name. So you could do it on the second name, but not the first name. In addition, because the prefixes end in vowels and the first letter of some of the elements are also vowels, what happens is sometimes you actually get two vowels that back up to each other. The two common problems are an O and an O, and like an A and an O. And typically we would get rid of the prefix off of the a vowel off of the prefix part of the name. So an example of that would be something like this: CO, capital C, capital O. That's carbon and oxygen. They are both nonmetals, which means it's a type 3 compound. You don't have to worry about charges. You don't have to worry about balancing things. You frankly just need to count how many of each you have and pick the right prefix. So carbon, I only have one, which means the prefix is mono, right? Do I use mono on the first name? I don't. So we're going to drop the mono and just use the whole name of the element. So that would be carbon. There's only one oxygen. Prefix is mono. Can I use mono on the second name? I can, so that's okay. So if you write mono, and then the oxygen becomes oxide, and you end up with carbon monoxide. They do not sell, right, carbon monoxide detectors. They sell carbon monoxide detectors, yes? And that is because, I don't know why that's because, but it is because we should get rid of that first O, and this really should be called carbon monoxide, with just the one O that's present. So we would get rid of that O off of the prefix and squeeze it together, and it then should be called carbon monoxide. Yeah. Any questions on that? So first element first in the name, second, guess the IDE. And if you have a name, same way, the first name, part of the name is the first guy in the formula. Second part is the second guy in the formula. So here's again some of those rules. And the prefix, again, mono not used, but okay on the second name. Oddly, two I's in a row are okay, but really it's the OO and the AO sort of combination that you have to get rid of some of those. Here's a little table, those prefixes and what we just talked about. And here's our considerations. Again, tetraoxide, we would drop the A, and it would just be tetraoxide, no A there. And again, there's our mono that we would drop as well. And of course, water would be H2O still, not dihydrogen monoxide, or any of the favorite things I read on exams when I put water up there and all the funky names that people think get to put. Ammonia, again, is ammonia, not nitrogen trihydride either, so you should call it ammonia. And I think we added our methane to that list earlier. So methane as well is what you should call that. All right, so why don't we try a couple of these, and when we give you some names, a little dinitrogen, I don't know, pentoxide. Let's do a little sulfur hexafluoride. And let's do a made up thing of trioxygen. Maybe it exists somewhere. Who knows? Trioxygen, I don't know. Hexabromide, I don't think so, but we'll go with it. All right. So I give some names there on the left and give some formulas on the right there. Again, I'll write a little higher in case you need here. I2O7, CO2, and ECl3. Fastest ones did you do? But again, sometimes people really kind of mess up on these because they want to do weird things. So you still want to approach it the same way. What are we dealing with? So we'll take the first one here on the left. We have iodine, which is a nonmetal. We have oxygen, which is a nonmetal. So right off the bat, that should tell you it's a type 3, and that is prefix territory. That's a nice thing as well, because I don't have to worry about balancing charges or anything like that. I simply just need to pick the right prefix that goes with how much I have. So I look at the I and I see a 2, which means the prefix there is going to be di. Again, the first element, we use the whole name of it. So this would be diiodine. I look at the second element, that's a 7. So the prefix is hepta. And oxygen there will now be IDE at the end because it's the second element. And this will be a little hept oxide. Here I am going to drop the A off of the prefix so I don't get the A and the O combination happening. Any questions on that one there? Same thing for the next one. I'm going to look at it and go, C is carbon nonmetal, O is oxygen nonmetal, type 3 prefix, ready to roll. One carbon prefix is mono, but I know I should not use that on the first name. So we're just going to use the whole name here, and that would be carbon. There are 2, so the prefix for that is di. And again, the second element gets the IDE at the end of it. So this would be carbon dioxide. Yeah. Any question on those 2? Lastly, here I see P, which is a nonmetal, Cl, which is a nonmetal. So type 3. We only have one phosphorus, so we are again not going to use mono on the first name. So this would be the whole name, phosphorus or something. 3 prefix is tri. Second guy gets the IDE, so this would then become trichloride. Yeah. Any questions on any of those names there? No. So this is where we use prefixes. Again, nowhere else. The easiest of any naming you'll ever do is this one right coming up right here. This is probably the easiest of it all. I see tri, I see hexa. That makes me think type 3. I don't have to worry about anything other than write what it says. So tri is 3, oxygen is O. That's an O and a 3. Hexa is 6, bromine is Br. That's a Br and a 6, whatever that might be. Would be the formula there in that particular case. Again, I see di, which is a prefix, penta, which is a prefix, so could roll right into the formula. Nitrogen is N, di means 2, penta is 5, oxygen means O. So there it is, N2O5. Lastly, on the last one, I see sulfur, no prefix, but I do see hexa, which is a prefix, and I know the only place prefixes should be used is type 3, and they're both nonmetals as well, right? So I know that's going to be type 3. So sulfur with no prefix means there's only one, because that's our mono we're not using, right? And hexa is 6, and Cl is chloride. So a little bit of that action, yeah? Any questions on that there? All right, so everybody has its place of where it goes. Prefixes only for type 3 should only be used in non-metal action happening there. Roman numerals should only be used in a metal, non-metal situation where the metal is a transition metal or just to the right. None of the above in a type 1 situation, no Roman numerals, no prefixes, just the whole name and the IDE for the metal non